Welcome, my dear students. This class on tangents and secants, we are going to discuss different kinds of problems, and right, they are very important for your public examination point of view. On part of this, we have prove that the center of a circle lies on the bisector of the angle between two tangents drawn from a point outside it. Prove that the center of a circle lies on the bisector of the angle between two tangents drawn from a point outside it. Let us draw the diagram and we will try to understand very neatly this particular thing. That means what we require to prove is, right, my dear students, here we have got that a circle we have got here like this, right? We got a circle like this and a point P outside of it like this. Now from the external point we can draw two tangents to this. Let us call this as A and B, and O is the center of the circle like this. O is the center of the circle. Once you have got the things like this, now OA and OB, if you draw, they are perpendicular to this. They are perpendicular to the tangent at the point of contact. Now prove that the center of a circle lies on the bisector of the angle between two tangents. Now these are the two tangents what we are having here. PA, PB are the two tangents. We need to prove that now OP is the angular bisector. Okay, from a point outside it. We need to prove that OP is the angular bisector of this. The circle lies on the bisector of the angle between two tangents. That means we need to prove this angle is equal to this angle, right? My dear students, the information is very clear. Now, my dear students, we know that actually this is 90 degrees. This is 90 degrees in these two triangles. You see here, if you consider the triangles here. If you consider the triangles, what triangles you are going to consider? OAP, comma, OBP, like this. OAP, comma, OBP. Consider the triangles OAP, comma, OBP. You are having here triangle OAP is congruent to triangle OBP, like this. OAP is congruent to OBP, right? How they become congruent? That means I am telling this is right angle here. Okay, how they are congruent means because angle OAP, if you take, is equal to angle OBP, like this. Angle OBP, this is equal to 90 degrees. This is what right angle you are having here, of course. And OP is equal to OP. This is what the hypotenuse, right? And you know that OA equal to OB, OA equal to OB, because they are the radius. Okay, by RHS congruency they are congruent like this. By RHS congruency they are congruent like this, my dear students. Therefore, what we can say by CPCT, like this, we can say that okay, angle, okay, APO or OPA, like angle OPA. Okay, angle OPA is equal to angle OPB, like this. Angle OPB, like this, right? Because by CPCT we got this angle equal to this angle. That means if this is X, means this is X. And this is what actually we require to prove. OPA equal to angle OPB, right? Therefore, we have got that the center of the circle lies on the bisector of the angle between two tangents drawn from a point outside it. Like this we have got. Now we need to prove this angle equal to this angle. That is what we have got. Angle OPA equal to angle OPB. That means both are equal to X, right? Now see, my dear students, this problem, the second one, prove that in two concentric circles, a chord of the bigger circle that touches the smaller circle is bisected at the point of contact with the smaller circle. That is what we require to prove. See how we will do this beautiful problem. We are having a bigger circle like this. And we have a smaller circle. Both are concentric circles. Like now, the chord of the bigger circle which touches the smaller circle at a point like this. Yeah. Right? This is what O we are having here. Right, now the chord you have here A, B, like this. Now we need to prove that a chord of the bigger circle that touches the smaller circle is bisected at the point of contact. This is what okay, we have to prove that now. Okay, is bisected. This is equal to right? Now let us take this as C. Now we need to prove AC equal to CB like this, right? We need to prove that AC is equal to CB. How we are going to do it? It's a very simple, my dear students. See here, we know that this is 90 degrees. Why 90 degrees? We did already one theorem. At the point of contact to the tangent, the radius will be perpendicular to the tangent at the point of contact like this, right? Very good. Now we need to, if you prove that these two are congruent, then let us consider now here, you see here, consider triangles triangle OAC, OBC like this, OAC, OBC. Consider triangles OAC, OBC. In this, you see, my dear students, what you are going to have, angle OCA is equal to angle OCB, that equal to 90 degrees. That is what the right angle. Next, you have here, OA is equal to OB, right? Fine. OA equal to OB, because there is radius of the bigger circle. That is nothing but the hypotenuse of these two triangles, right angle, hypotenuse, one side. Let us take OC is equal to OC. That is the common side. Therefore, by RHS congruency, what you can say, therefore, by RHS congruency, we can say that triangle OAC is congruent to triangle OBC like this. OAC is congruent to triangle OBC like this, right? My dear students, triangle OAC is congruent to triangle OBC. Therefore, by CPCT, we are going to get, see here, by CPCT, what you are going to get, AC is equal to BC. That is what now we proved, right? See here how beautifully we have got this AC equal to BC. That means this chord is bisected. Bisected means we have got C as like the midpoint. We have got AC equal to BC means C is midpoint. Therefore, this bigger chord is bisected at the point of contact to the smaller circle. That is what we require to prove, right? Wonderful. Now see another beautiful problem, my dear students. If two tangents AP and AQ are drawn to a circle with center O from an external point A, then prove that angle PAQ equal to 2 times of angle OPQ, that equal to 2 times of angle OQP. This can be understood very easily only when we draw the diagram. Without diagram, this theory we cannot understand properly. See, my dear students, we have here drawn to a circle with center O from an external point A. We are having here like this. The circle is this. We have this circle like this, right? For this circle, if you have an external point A, AP and AQ are drawn to a circle with center O. This is what center O we are having like this, right? AP and AQ. We have here AP and AQ are the two things we have here like this. AP, two tangents. From this, what we have here like this. Here P and this is Q like this. Now like this and like this. This is perpendicular as we know that. Now fine. Now what we require to prove angle PAQ. This PAQ is equal to 2 times of angle OPQ. OPQ means here we have to draw like this. Wonderful. Right? Fine. This is what we require to prove angle PAQ is equal to, this PAQ is equal to 2 times of angle OPQ. That equal to 2 times of angle OQP. Right? This is what we require to prove, my dear students. How we are going to do this is, fine. This is what, we require to prove. Now how we are going to deal this, you please observe. Now see this particular problem, how we are going to do, my dear students. We know that, let us take angle PAQ. We don't know this angle PAQ. Let us take this as some, right, theta or x or anything you can take like this, right? Once we have taken this like this, my dear students, what we are going to have, right? Here, angle APQ plus angle AQP. Angle APQ plus angle AQP plus, see this one, AQP plus angle PAQ. This is equal to, you have 180 degrees minus 180 degrees, right? Now from this actually you see, my dear students, angle APQ plus angle AQP is equal to 180 degrees minus, okay, 180 degrees minus angle PAQ. PAQ is nothing but theta. That is what we have mentioned here, of course, right? That is nothing but 180 degrees minus theta, right? Wonderful. Now you know that one thing here, these two tangents are drawn from an external point. Those lengths are equal. Therefore, these two angles are equal. If these two angles are equal, what we are going to get? 2 times of angle APQ, this, and this is equal to 2 times of angle AQP, because those two angles are equal. Then you will be getting this is equal to 180 degrees minus theta. From that angle APQ, what you are going to get is, right, or AQP, this is AQP, like this, not B, it is P. This is equal to, you are going to get 180 degrees minus theta by 2. That means 90 degrees minus theta by 2, like this. 90 degrees minus theta by 2, like this, right? Fine, wonderful. Now this we have got wonderfully, right, my dear students, 90 degrees minus theta by 2, this. And here also, this is also 90 degrees minus theta by 2. Now we need angle OPQ. OPQ, you know that actually this is angle OPA. I need, actually what I do is angle OPQ, right? This equal to angle OPA minus, right, angle OPA, this total angle minus, I will just subtract angle APQ, like this, right? Angle OPA is actually 90 degrees. You know, this is angle OPA is 90 degrees because it will make 90 degrees at the point of contact, minus 90 degrees minus theta by 2, like this. Now 90 minus 90, minus into minus plus, this become theta by 2 we have got. Now angle OPQ is equal to angle OQP, because this is the radius you are having here, then their opposite angles are equal. That's why what you are going to get is angle OPQ is equal to angle OQP, that equal to theta by 2 you have got, right, that equal to angle theta. Actually we told that angle PAQ equal to theta, like this, right? That means you have got this as angle PAQ by 2. Therefore you have got angle PAQ is equal to, if you multiply this, 2 times of angle OPQ, that equal to 2 times of angle OQP. Wonderfully you have got the problem like this, right? Wonderful, right? See, my dear student, next we have one more wonderful problem. If a circle touches all the 4 sides of a quadrilateral ABCD at points PQRS, then prove that AB plus CD equal to BC plus DA. This is what we require to prove. How we will do this solution part, my dear students? You see here, we have a quadrilateral like this, right? We have a quadrilateral, right? Something you take, anyway you can take like this, just I am taking like this. ABCD is a quadrilateral, like this is what ABCD is a quadrilateral we have. And a circle is touching all the 4 sides of a circle is like this, right? It touches all the 4 sides of the quadrilateral ABCD. Let us call them as at the points. So we given that this is PQ, R and S, like this. Now you need to prove that AB plus CD is equal to BC plus DA. This is the diagram, wonderful diagram. Now you see, my dear students, I can say that from this diagram AP is equal to AS, because from an external point, if you draw 2 tangents, their lengths are equal, right? AP is equal to TS, you can say like this. Next, BP is equal to the same concept. From external point B, if you draw 2 tangents, their lengths are equal. BP equal to BQ. Now you have here BP equal to BQ. Wonderful. Next, in the same way, my dear students, we have here CR is equal to CR. C is an external point. From that, if you draw tangents, their lengths are equal. CR is equal to CQ, right? Next, you have here DR. DR is equal to the same way, equal to DS, like this. Now let us add all these things. left hand side, if you add them, you have here AP plus BP plus CR plus DR is equal to, you are having here AS, right, plus BQ plus CQ plus DS, like this. AP plus BP is equal to what you are going to get? AB plus CR plus DR, this is equal to CD. Okay. Next you have here AS plus DS. These two if you combine like this, AS plus DS, then you are going to get, right, what you will get? No, AD. Next BQ plus CQ, that is nothing but BC. You are going to get that is nothing but BC. Therefore AB plus CD equal to AD plus BC. Such a wonderful way we have got this particular problem in a very simple and elegant way, right? See, now this fifth one, it is a 5-star rating problem. Many times they have asked, my dear students, it is a 5-star rating problem like this. So very, very important. Draw a pair of tangents. It's a construction, right, to a circle of radius 5 centimeter, which are inclined to each other at an angle 60 degrees, which are inclined to each other at an angle 60 degrees. See how we are going to do the solution part, my dear students. Pair of tangent to a circle of radius 5 centimeter. Now you are having here a circle like this of radius 5 centimeter, which are inclined to each other at an angle 60 degrees like this. Okay. Now you see, my dear students, you are having this is one tangent and another tangent is like this, right? Wonderful, right? A circle of radius, we are having here the circle of radius like this. I am just drawing the rough diagram, but actually we need to do the construction part. For that, what we require, we need the distance from center to the external point. For that, I am just drawing like this. Now we need that they given that radius is 5 centimeter. This is O and this is P. This is A and B. But we want now OP. If you know the distance between center and external point, then only we can able to get. And they are making each other 60 degrees angle. This is what 60 degrees. Actually, we proved, my dear students, by RHS congruency, OAP, triangle OAP is congruent to triangle OBP. That means these two are equal. Equal means what? This is 30 degrees, right? Once this is 30 degrees, this is 90 degrees, then we have here this is 60 degrees. And right, here also this is 60 degrees we have. Now we know we can apply the trigonometry also, right? We need what? OP. We know that sine 30 degrees. Sine 30 degrees is equal to opposite side. Opposite side means OA. OA by hypotenuse. Hypotenuse is what? OP. You are having like this. OA is radius. Therefore, from this sine 30 degrees is 1 by 2. 1 by 2 equal to 5 by OP. OP is equal to 10 centimeters you will get. OP equal to, now we have got this as 10 centimeter like this, right? My dear student, now we have got the distance. Okay, this is only explaining about, right, how we have got the distance between the center and the external point. Now we know how to do the construction part, my dear student. Now with radius 5 centimeter, you see here I am explaining to you, right? We got now this thing like, right? We have got OP equal to 10 centimeter. Please remember this like, okay? Now we will do the actual construction. You see how we are going to do the construction. Now you first step 1, you draw a circle with radius 5 centimeter. Next, okay, step 1 is this, radius 5 centimeter. You take compass and draw a circle with radius 5 centimeter. Okay, you take OP, this is an external point. You have here with 10 centimeters, right? You draw, okay, with the OP equal to 10 centimeters you are having here, of course, right? Wonderful. Now, okay, 10 centimeter, we know that. Next, what I told you is the third step is you take compass, you take more than half of OP. More than half of OP, you draw one arc here like this. Here you draw one arc like this here. Similarly, without disturbing these measurements, with P as center, you cut the previous arc here. You cut the previous arc like this here. Then you got, this is what? The perpendicular bisector of OP. Let us call this as some M like this. Next step 4 or 5. You take M as center and OM as radius. Okay, because these two are equal, or MP as radius. With M as center, you draw one nice circle like this, Nana. Okay, if you draw a circle This will intersect the given circle at 2 points. You call that as A and B, like this. Now you join PA, you join PB. Now PA and PB are the two required tangents. That is very obvious because this is a circle. You know that how they become tangents means we know that in this circle this is acting as a diameter means this angle equal to 90 degrees, right? This is 90 degrees. Similarly here this is also 90 degrees. That means only the tangent will make 90 degrees with the radius. This is what the radius at the point of contact. We have got this as 90 degrees because the angle in a semicircle is 90 degrees. This is the construction, the steps what we did that you do one by one. Now the proof is what, how to prove they are tangents means, as you know that my dear students, angle OAP is equal to angle OBP. This is equal to 90 degrees because angle made by a semicircle, angle made by semicircle like this is 90 degrees. This is what, 90 degrees, right? Wonderful. Angle made by semicircle is 90 degrees. Once this is 90 degrees means this becomes the tangents like PA and PB. Only tangent will be perpendicular to the radius at the point of contact. Therefore, PA is equal to PB. You have got, and PA comma PB are the required tangents. Are the required tangents. You are having like this. Like this you can do this beautiful construction. Right? Now we have another important concept. By this the total chapter will be closed. Area of the segment of a circle. How to find area of the segment of a circle means, my dear students, first of all you should know what you mean by the segment of a circle like this. Right? You see, we know that actually some basics I will explain to you. Suppose we are having here, you should know minor arc, major arc and minor segment and major segment. These things you have to understand perfectly. Right, my dear students, suppose what you mean by a minor arc. Suppose I am taking an arc AB, right? If this makes an angle less than 180 degrees at the center, then you call this arc as minor arc. This arc you call it as minor arc. And the other one, this is what now we have here AB. This is okay. If I take ACB, something, some midpoint B, some point C, okay, to get a proper meaning. ACB is a minor arc. Next I am having here D. I am just taking some. Now ADB. This is a major arc. This is what now? Major arc. This is what, this angle is greater than 180 degrees. This is what now? Major arc, like this, right? Wonderful. Now what do you mean by minor segment and major segment, and what do you mean by segment? Now if I join these 2 points, of course, right? Now if you join these 2 points, now you see this area, okay? The area enclosed by the minor arc and its corresponding chord, okay? Minor chord, what we call this? This area you call it as minor segment, like this. Minor segment area, right? Like this. And the other area, this is what you call it as a major segment area. This is what? Major segment area. Major segment area, like this. Right, my dear student, now we need to find area of the segment of a circle. How to find area of this segment? Okay, once you get area of this segment of a circle, then the other segment you can easily find, because by finding area of a circle and subtracting the minor segment area, you will get the major segment area. You will get the major segment area very nicely, right? My dear students, this is what the thing what we are having in this. Now how to find this segment area? Now that's what we will do now. You see, my dear students, this is what you have here. Now I am having here like this. The circle is like this, right? I am having a segment, as I told you that AB is a segment, right? In this AB is a segment, I told you I want to find this area like this. For this what I do is, let us take this total like this. Okay, I know how to find sector area. Before going that, we know how to find sector, this total sector like. Okay, that sector area of sector, right? Area of sector is equal to what, Nana? Theta by 360 degrees into pi r square, because that is part of the area of the circle. Arc is part of circumference, where sector is part of the area of the circle, like this. Area of sector equal to theta by 360 into pi r square. We have got. Now from that sector area, if I subtract this triangle area like this, if I subtract this triangle area, then I will get this remaining part. This remaining part, what we have here, this remaining part we will get. That is what the area of the segment of the area, right, my dear students? That is the concept what we are having here. How we will do now the area of see this segment, area of segment ACB, something like this, right? ACB, area of the segment ACB, that is equal to, how we are going to get area of the segment ACB, that is equal to, how we are going to get, you see my dear students, area of sector AOB, from this area of the sector AOB, or this one, yeah, area of sector, this is area of sector, right? Sector means this total, OAB, right, minus area of triangle, area of triangle OAB, like this, area of triangle OAB. From this total sector area, if you subtract area of this triangle, then you will get area of this segment. That is what the concept. Area of the sector OAB, now only we got nana, that is theta by 360 degrees into pi r square, minus area of triangle OAB, that become half base into its height. If you draw the height and if you draw like this, so you will be getting that, minus area of triangle OAB. This will give you area of the segment, okay, ACB. This is what area of the segment ACB will give you, area of the sector OAB minus area of triangle OAB. That will give you the area. Now based on this, we are going to do some nice and wonderful, interesting problems. See my dear students, now all the problems on this, now based on area of the segment of a circle, what we have discussed. On part of this one problem now, the sixth one, find the area of the segment AYB. This is what the segment AYB we need to find, like this. If the radius of the circle they given 21 centimeter and angle AOB equal to 120 degrees. I told you my dear students, first we need to find area of the sector AOB, right? Area of the sector AOB, right? How you do is, okay, from the area of the sector we are going to subtract this AOB triangle, then we will get area of the segment. Now you see, area of sector is equal to, right, actually area of the segment, actually we need to find area of the segment AYB. This is equal to area of sector, right, OAB, area of sector OAB minus area of triangle, okay, OAB, like this, area of triangle OAB, this one. Now area, let us find area of, now these two things if we find and we subtract, then we will get our thing like that. Area of sector OAB, that is equal to, right, wonderful, theta by 360, okay, theta by 360 into pi r square, this. Now this is theta is what, 120 degrees divided by 360 degrees into pi r square, pi into 21 square, like this. 121, so 123s, like this we have here. Now this is equal to actually pi into 21 into 21 by 3, 3 1s, so 3 7s. We have here got area of the sector, my dear students. From this, what we will be getting is 462 square centimeter. This, if you simplify, you will get 462 square centimeter, where you use pi is equal to 22 by 7, like this. We use pi equal to 22 by 7. That is what area of sector OAB. Now we want area of triangle OAB. Now area of triangle, okay, OAB. This is equal to, you see my dear students, one thing I will do, if I draw the perpendicular here, it bisects the chord. You know, in circle, if you draw the perpendicular, it bisects the chord. That means these two are congruent. This is radius and this is 90 degrees, right angle, hypotenuse and common side. These two are congruent. Then you will get this is 60 degrees, this is 60 degrees. Right, my dear students? Then, okay, this is 90. Then you will get this is 30 degrees. Right, let us call this as some symbol C like this. In triangle, okay, fine. What we are going to get area of that is nothing but in triangle, my dear students, to do that, in triangle OAC, we know that, okay, I want now this height, I want this height and this one, right? Sine 30 degrees if I take, sine 30 degrees is equal to this one OC by OA like this, right? OC by OA is 21 like this. Sine 30 degrees is 1 by 2 like this you are having here. Now, from this OC is equal to 21 by 2. 21 by 2. OC is equal to 21 by 2. Wonderful. The height you have got OC. Now we need AC. AC means we let us take here cos 30 degrees here like this. Cos 30 degrees if you take here. Adjacent side by hypotenuse. That is what we have here. Cos 30 degrees is root 3 by 2 is equal to AC by 21. From that AC is equal to 21 root 3. 21 root 3 by 2 like this. Now we need AB. AB is nothing but because okay, C is midpoint, 2 times of AC. 2 times of AC. That if you do, what you are going to get? Okay, 2 into 21 root 3 by 2 like this. Right? That's the thing what we have got now. Like. Now see this 2 will cancel. You have got 21 root 3. Now we got AB also we got. Now area of triangle OAB here is equal to half into base. Base is AB. AB is 21 root 3. 21 root 3. Right? This is what you have here. 21 root 3 base. Half into base into height. Height OC. OC is 21 by 2. Like this. Right? If you do simplification, you will get area of triangle OAB. Now we need area of the segment. Right? Therefore, area of the segment we have here. See, my dear students, area of the segment. Yeah, area of the segment. This is equal to AYB. AYB, we told already that area of the sector OAB. Area of the sector is nothing but what? 462. This is what we have here. 462 minus, right? Area of the triangle. That area of triangle, now only we got that half into base into height, that is 21 into 21. If we do that 441 root 3 by 4, this is now 441 root 3 by 4 like this. 441 root 3 by 4 like this. That if you simplify that, you will get 271.0. Just you simplify that 047 square centimeter. This is what area of the segment you are going to get. And root 3 value is 1.7. You take and you do. In this beautiful way, we will be getting this particular problem. Right? You see, my dear students, this is another important and interesting problem. The application. A car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeter. Sweeping through an angle of 15 degrees. Find the total area cleaned at each sweep of the blade like this. You see, my dear students, it is having two wipers. My dear students, you know that wipers like this. They sweep like this. This is one wiper we have here and they do not overlap each other. Like this is another wiper we have here like this. They given that the blade of length, this is the blade of length 25 centimeter they have given like this. Right, my dear students, this is just a rough diagram. This is also 25 centimeter. And they have given that the angle is 115 degrees. This is 115 degrees. This is also 115 degrees. Now we need to find the area, total area cleaned at each sweep of the blade. That means we need to find, this is something like a sector. Like this is a sector, my dear students. We need to find these areas. Sum of these two areas. It's a very simple thing. Like the areas. The required area we are going to get, you see, the required area is very simple, my dear students. 2 times of, because both are identical, 2 times of theta by 360 degrees into pi r square like this. Now 2 into theta, theta is 115 by 360 degrees into pi into r square is 25 square. Just you simplify this, you will get the area. That's all this problem. Right, my dear students? If you simplify that, you will be getting the area of that. Wonderful. Next. See, my dear student, next problem, very interesting problem. We have a square here, ABCD is a square. This is one semicircle like this here with AB as diameter and CD as diameter with another semicircle you are having. Now AD, okay, as diameter, one more semicircle you are having, and BC as semicircle, we have one more semicircle like this. Right, this is a square. ABCD is a square. Now we need to find, the problem is this part, this shaded part we require to find. Now I will give the way, the procedure, how you will be doing that. This shaded portion is a very important star marked, 5-star rating, right? Because many times this problem was also asked. This is the area we require to find. How we are going to find? Okay, fine. They given that ABCD is a square of side 10 centimeter. This is equal to 10 centimeter, right? Now if this is center of the semicircle, means this is 5 centimeter, this is 5 centimeter. You are having, we need to find the area of this shaded portion. What I have shaded, that is what we require to find. Wonderful. You see, my dear students, how we are going to do to find this shaded area, right? See, my dear student, here the logic, how we are going to find these strips, this strips area. I am doing one thing, my dear student, here this semicircle area I will find. This semicircle area I will find. That means these two combinedly one circle. Next, okay, this, see actually the rough diagram what I am doing is, right, this is one semicircle, this is another semicircle, right? Wonderful. Next, I will do this, I will find another semicircle and I will find another semicircle like this, right? If I find that, what I am getting is, from actually this part how we have got is, from the total two circles area, if I subtract this square area totally, then I will be getting this part is what the shaded portion, right? That is what the shaded portion. Therefore, required shaded area is nothing but very simple, my dear students. You are going to get, see, this is one semicircle, this is one semicircle, and this is one semicircle, this is totally 4 semicircle. 4 into pi r square by 2. Here area, okay, 5 into 5 square, pi r square, 5 square by 2, like this. Now, 2 1s to 2 2s, we have here 50 pi, okay. This is what total area of this total, right, minus area of the square what I told you, of course. Area of the required shaded area is nothing but, okay, this total area minus what I told, area of square here. Area of square like this. If you do, this is now 50 pi, okay, centimeter square minus area of square. Area of square is nothing but what? 10 into 10, 100 centimeter square like this. Now 50 into, my dear students, pi is 3.22 by 7, 14 minus 100 centimeter square. That if you simplify, you will be getting the required area. See, once again, my dear students, what I am explaining is here, how you will be doing is, you just concentrate here, how we have got this area. Means, I am doing this semicircle, and this semicircle if I do, that means 2 times of the circles. Okay, from that if I subtract this total square area, I am going to get this shaded portion. That is what I did here. Required area is nothing but 4 times of these. Why 4? This one semicircle, this one semicircle, this one semicircle, this semicircle. 4 times of pi r square by 2 is area of the semicircle. Okay, that's what 50 pi minus area of square. That area of square if we subtract, we are getting 100 square centimeter. If you simplify this, you will get area of the shaded portion. Like this, in this beautiful way, you will be getting this problem, my dear students. Have you understood? Here, therefore, I have explained all the models which are required to do this topic tangents and secants. You just go through all example problems and constructions. Okay, you can do very well these exams, right? Okay, now our syllabus is similar triangles and tangents and secants. We totally completed this portion. Now you are well enough to write the exam. Please go through all the examples and practice well. All the best for you. Please pay the fees and also subscribe to my channel. Thank you very much.